I'm Felipe Bravo. I'm professor of forest management at University of Valladolid.
My name is Doan Minh, and I'm from Vietnam. I'm a PhD student under the double degree program, thanks to the collaboration between the University of Valladolid and Vietnam National University, and my PhD is under co-supervision from Professor Felipe Bravo Oviedo and Associate Professor Dr. Vũ Văn Mạnh.
My name is Nhat Linh. I'm a lecturer and also a PhD student in VNU University of Science, Hanoi, Vietnam.
My name is Kinh. I'm a PhD and lecturer in VNU Hanoi University of Science in Vietnam.
In this work, we are developing an artificial intelligence approach to be able to mapping carbon in the evergreen forest in northern Vietnam. This is part of the cooperation between University of Valladolid and Vietnam National University that we conducted during the last 7 years.
So in order to conduct the work, we obtained the data from two telescopes located in Hanoi, the capital city of Vietnam, and also other 4 permanent sample plots located in different cities, different provinces in Vietnam. The telescope in Hanoi representing the Red River Delta ecoregions and other permanent sample plot representing northeast and northwest ecoregions of Vietnam. The two telescopes involved in this research were obtained from the BioEcon projects, and here are the two telescopes. Telescope Core 43 from the campus in Hoa Lac of Vietnam National University, and so is the telescope in Mook Mountain. In each telescope, we have each telescope is 1 hectare area, and in which all the trees with diameter at breast height of greater than 5 centimeters will be recorded, identified, measured, and also georeferenced. Together with the two telescopes, we obtain also 4 permanent sample plots provided by the Forest Inventory and Planning Institute, which is the agency units from Ministry of Agriculture and Rural Development of Vietnam. Each permanent sample plot has the area of 100 hectares, and in each permanent sample plot we divide it into 3 sub-PSP, which is research plot, where every tree above with a diameter at breast height above 5 centimeters will be identified, recorded, and also georeferenced. And here we are looking at the example of the permanent sample plot number 11, where you can see the different forest status is representing by polygons in different colors, and also the coordinated of each individual trees. The tree biomass will be calculated using different allometric equations obtained from different references.
So based on the ground data we collected from the field, and nowadays we can calculate the ground biomass based on the equation, and then after the biomass we can choose the threshold and classify them into different levels. And this will be the levels for the next level. But based on that, we have the data, input data from the multi-temporal remote sensing, called often from CNN to sensor. And the resource solution of this remote sensing data is 10 meters. And from the remote sensing data, we can calculate different types of the remote sensing indexes. For example, with the light, the PAPA, and also the NDVI and the S2 rep. And in total, we have about 10 remote sensing indexes, and then we can compare with the data output from the biomass, and then the whole data can be divided into groups, into training tests, data sets, validation, and testing data, and then based on different type of machine learning, and we can choose the different optimization, and then we can choose the lowest mean square error, and also the highest value of the accuracy. The best model will be can have the we propose it will be the more than 7 or 80%, but the best one will be used for the to predict and also to classify the forest biomass in the future. And as the important data from for the remote sensing and also for the machine learning model, and based on, and we have about 1,500 samples from the point, and then because that's values can be obtained from the ecological point from the different remote sensing data, and also from the location of trees obtained from the field. And because of the from material scope, and we have about 1 hectare areas, so we can convert it into the biomass, and also merge it with the remote sensing data, with the 10 remote sensing data, and then the total area information and data will be put into the next step for the machine learning development.
In this study, we are conducting experiment with some machine learning models such as support vector machine, linear discriminants analysis, random forest, K nearest neighbor, and also XGBoost. Now we will see what the result that we have. It can be seen that our models are quite satisfactory with the outputs of 3 classes of biomass. They are high biomass, medium biomass, and low biomass. Currently, random forest is the best model with the accuracy about 67%. This work is partly funded by the European Union's different organizations from Spain and Vietnam. We also thank Felipe and the BioEcon project for their support of providing data. For more information, you can scan QR code here to get our PDF version. If you have any question, please let us know. Thank you so much for your attention.